You've probably heard the term deep learning thrown around a lot. And let's be honest, it can sound pretty complex, maybe even a little intimidating. But what if I told you it's really just a clever way to solve a very human kind of problem? It's about teaching computers to do things that, for us, feel like pure intuition, like recognizing a friend in a crowd or understanding what someone means when they speak.
I mean, really think about it. How would you write code with a bunch of if-then statements to reliably identify a cat? One cat might be curled up in a ball, another might be stretching, another might be just a pair of ears poking out from behind a sofa. The number of possibilities is basically infinite. This is where traditional programming just hits a wall. You can't write rules for everything.
So that's our goal for the next few minutes. We're going to demystify this. By the end, you'll have a solid mental model for how these systems actually learn to make sense of all that messy real-world data.
All right. The central idea behind deep learning is actually inspired by a fantastic piece of engineering, the human brain. The key insight is that our brains don't try to process everything all at once. Instead, understanding is built up, step by step, in layers.
Let's use an analogy. Imagine you have a team of specialists looking at an image. The first layer of your team, well, their only job is to spot the most basic things. A straight edge here, a curve there, a patch of a certain color. Super simple stuff. Then, the next layer of specialists takes their reports and combines them. They might say, okay, I see a few curves and lines coming together. That looks like a circle. The layer above them takes that information and assembles it into something more meaningful, like an eye, a nose, or a pointy ear. And finally, the top-level manager looks at all these collected features and makes the final call. Aha, I see 2 pointy ears, a nose, and whiskers. That's a cat. See how we went from simple pixels to a complex idea? That's the core of it.
Now, this layered system has a formal name, an artificial neural network. It's a network of simple software modules, which we call neurons. And the deep part of deep learning, it's not mysterious at all. It just means the network has a lot of these layers stacked one after another. That's it.
This layered approach is really different from older machine learning methods. You can think of traditional ML as trying to find one single, very clever, and often complex mathematical formula to explain the data. Deep learning takes another route. It uses millions of incredibly simple functions, our neurons, that all work together. This makes the whole system unbelievably flexible. In fact, deep networks are known as universal approximators, which is a fancy way of saying they can learn to mimic almost any pattern you give them just by combining tons of simple pieces.
So, we have this powerful, brain-inspired structure. But how does it go from being a random collection of layers to something that can actually learn? Let's talk about how the network gets tuned. Every single connection between the neurons in our network has a set of tiny tuning dials. Technically, we call these weights and biases. A weight just controls how much influence one neuron's output has on the next one. And the entire process of learning, it all comes down to finding the perfect setting for every single one of these millions or even billions of dials. We find those perfect settings through a process called training, and it's really just a simple feedback loop, repeated over and over. First, the network takes an input, say our cat picture, and makes a guess. Maybe it says, dog. Then it compares its guess to the right answer and calculates how wrong it was. That's its error. Finally, it uses that error signal to go back and make tiny, tiny adjustments to all of its internal dials so that next time, its guess will be just a little bit better. Now, you might be thinking, with billions of dials, how does it know which ones to turn and in which direction? That sounds like an impossible task, and it would be, except for a couple of very clever algorithms. The most famous are backpropagation and gradient descent. We won't dive into the math, but what they do is provide a highly efficient way for the network to trace the error all the way back through its layers and figure out which dials were most responsible for the mistake and exactly how to adjust them. This is what makes training these huge models practical. The result of all this automatic tuning is a system that can be incredibly powerful and accurate, but there is a trade-off. Because there are billions of these tiny parameters all interacting in complex ways, it becomes nearly impossible for a human to look inside and understand exactly why it made a certain decision. This is what people mean when they call deep learning a black box.
Okay, that's the core intuition and the technical foundation. So where does this show up in the real world? Well, pretty much everywhere.
Deep learning is the engine running behind the scenes in most modern AI. When a self-driving car spots a pedestrian, that's computer vision powered by deep learning. When your smart speaker understands what you said, that's deep learning for speech recognition. It's in the recommendation engine that knows what movie you want to watch next. And of course, it's the fundamental technology behind all the new generative AI tools creating text and images.
And this is exactly why this concept is so important for any practitioner to understand right now. All the large language models and image diffusion models that are reshaping our field are built on these exact same principles, layered neural networks. They're just doing it at an absolutely massive scale with more data and more computing power than we've ever seen before.
So, if you need to boil it all down to one sentence, here it is. Deep learning uses layered neural networks inspired by the brain to learn complex, hierarchical patterns directly from data.
And that's the key takeaway to remember. The real power here isn't in any single neuron or any one clever trick. It's in the collective intelligence of the hierarchy, the way simple patterns are assembled layer by layer into a truly profound and useful understanding of the world.